All right, continuing on, we're going to do integral of e to the x and e to the u. So I don't think this lesson actually needs to be run for the most part because it's just kind of using intuition and things that we've learned before. So since the derivative of e to the x is e to the x, then its integral is also e to the x plus c. So, you know, if we see something like this, I know that integral now, I know that integral, I know that, and I know how to do this one. So, you know, this would just be x to the third over 3. This would just be x to the 3/2 times 2/3. This would just be 2 natural log absolute value of x, and this would just be minus 3 e to the x. And then there will just be a plus c on the end. So each of these has their own separate, essentially, integral formula that we know. So these are like kind of basic facts, and then we get into u subs with it. So for example, this one, e to the 3x plus 1. Well, if I set u equal to that exponent, then my du is going to be 3dx. So if I go in and I substitute, I'll get e to the u, but this doesn't match the leftovers, so I'll need to divide both sides by 3. Now we've got a simple integral, so we can say 1/3 e to the u plus c, or 1/3 e to the 3x plus 1 plus c. So, you know, kind of straightforward once we've got u substitution down and that sort of thing. So this next one looks significantly more complicated, but let's kind of follow that. I see e to an exponent. Let's try setting u equal to negative x squared. So du would be negative 2x dx. And that's actually pretty comparable here. I'm actually going to tweak this a little bit so I can think about it a little bit more simply. I see this is actually 5 times the integral of x e to the negative x squared. So the way that we could handle this is x e to the, okay, so looks like we're going to be able to have our e to the u here, and then if I can just divide both sides by this negative 2, now I have my x dx. So that 5 is still there, and it's going to be divided by a negative, or it's going to be times a negative 1/2, so it's really going to be negative 5/2 e to the u du. And now we just say negative 5/2 e to the u plus c. So when we go back and replace, there we go, all set. You know, and if you're not trusting that that's actually the antiderivative of our original, you know, we can always try to, you know, check it really quick by taking its derivative. So the negative 5/2 doesn't do anything. E to the negative x squared doesn't do anything. Then times the derivative of the inside plus c, well, that's a 0 when we take the derivative of it. And then if we go in and we simplify in here, the negatives cancel out. The 2's cancel out, and then we're left with a 5x and then e to the negative x squared. Well, look at that. Okay. All right, we get to our next one, and it's like, no. But remember, 1 over x, we're taking, if we were to set this equal to u, we take the derivative of that to find out what du is equal to. Remember that 1 over x is equal to x to the negative 1. So this is really saying multiply that by -1 and subtract 1 from that. Or better put, du is equal to -1 over x squared dx. Well, would you look at that? The only thing that's got a problem is that negative, so we can say negative du is equal to 1 over x squared dx. And all of a sudden, this has now become the opposite of e to the u du. Take the integral, drop back in our original u, and we're done. So only minor playing has been necessary for these three. It's really just been substitute in u and then see what happens. So, we can't stay completely simple. We need to see the more complex ones. This is not one of them, though. So I look at all of this, and if I were to see this sine x and try to set sine of 2x and set that equal to u, I know I've got a problem already because I would have u times e to something, and I don't want to handle that if I don't have to. So I'm going to focus on that exponent and try setting u is equal to cosine of 2x. Let's see what happens if we take our du. You may be tempted to write it like that, but there's more. We took the derivative of the outside and there was this inside piece, so I also have to multiply it by the derivative of the inside. Okay, so now we've got that, and we've got a fair amount of overlap. The only thing that we really have that's different is that 3. I'm going to pull the 3 out front. And so now I just need to take that -2 and bring it over here. Now we've got perfect overlap here. Those go away with -1/2 du. So 3 times -1/2 is -3/2 e to the u du. And so just like the problems on the previous page, all of this just turns into -3/2 e to the u plus c when we take its integral. So that's -3/2 e to the, cosine of 2x plus c. So just, be wary to actually put u where it belongs. Let's see, this next one is a little messy. There we go. Okay, so do I pick that for you or do I pick that for you? So remember, when we have a plus sign inside of an equal sign, that's usually a problem. Plus sign inside of a square root, sorry. That's usually a problem. So let's set u equal to 1 plus e to the 2t, which will make its derivative 2e to the 2t dt. So I see this is here. There's an extra 2, so we'll divide by the 2. So let's see what happens when we go in and replace stuff. So we end up getting our half out front. We get our, that's just du, and this is now the square root of u. That's not that bad. So we got our 1/2 times the antiderivative of this. Remember, this is u to the 1/2. So I add 1 to the exponent and get u to the 3/2, and then divide by 3/2, which is multiplying by its reciprocal. So you have 1/2 times 2/3 u to the 3/2 plus c, or better put, 1/3 u to the 3/2 plus c. Still even better put, dropping u back in. There we go. One other form, since this is 3 over 2, I could write this as the square root of 1 plus 2t cubed. That would be valid. That's the way we rewrite fractional exponents. Okay, now we get into one where it's kind of ambiguous. What's going to be the appropriate u to pick? So my gut is going with the denominator. So I'm going into this question blind. I don't know if that's going to work or not. So if I'm right, like, hooray, I got lucky. This isn't, I know the answer right now. So let's say u is equal to e to the x minus e to the negative x. So that would make du equal to e to the x minus e to the negative x, then times negative 1. Oh, hey, look at that. So du is going to be equal to e to the x plus e to the negative x, which is our numerator. And I'm wondering if there would be some overlap if we were to have done it the other way. So that would be an interesting thing to check out. I might check that out after this. So our integral turns into 1 over u du. So remember, the integral of 1 over u is the natural log of the absolute value of u. Then we have our plus c. So I'm supposed to do that in cursive. So natural log of e to the x minus e to the negative x plus c. Now that minus sign there, that prevents any splitting up. I can't split this apart into nicer things, so I'm done. But I'm curious, what would have happened if we had set the numerator equal to u? So if I set u is equal to e to the x plus e to the negative x, then our du would have still been e to the x, and then this would have turned into minus e to the negative x, which is the denominator. So that means that if we go back in, we have here's our issue. We'd be able to say the top is u, but I can't just go in and this is an e to the x minus e to the negative x on top. This e to the x minus e to the negative x is on the bottom. So that prevents, like, this isn't saying 1 over this times dx. This is saying this over 1. And so I don't actually have an ability to replace this because this is it's on the bottom the way that it is in the problem. So that makes us not be able to finish it this way. Okay. In our next problem, we have 1 over radical x times e to the radical x. So if we were to set u equal to, if I set it equal to radical x, let's see what happens there. I'm thinking this is going to be a little bit of a problem because this would be 1 over u e to the u. And I don't know the antiderivative of u e to the u. So instead, I'm going to try setting e to the square root of x is equal to u. If I do that, du is equal to 1 over 2 root x dx. Nope. Times, sorry. I think I'm gonna get a new piece of paper. I'm out of room. And he professionally paused the video while he went over and got another piece of paper. This is me professionally pausing the video. All right. Look at that. Pausing the video and everything. 1 over square root of x e to the x. Oops, square root of x. Boop, 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 boop. All right, let's make sure we copied it correctly. Okay, so I'm going to say u is actually equal to e to the radical x. So then du is equal to e to the radical x times 1 over 2 root x dx. All right. So this is kind of interesting. If I were to put u there, I have a problem because I can't go in and then fit du in there. But let's see what happens here. So let's see. If I say the integral of 1, there's a u here. And so du is going to be, I can multiply both sides by 2 and say 2 du is equal to e to the radical x times 1 over radical x dx, which that's there. So what if to get this, because I have 1 over radical x dx, I have the u. Let's divide both sides by e to the x and get 2 du over e to the radical x is equal to 1 over radical x dx. So now that I have 1 over radical x dx, I can replace that with this. But that, I still have x's and u's mixed up with each other. But now I have another e to the x that I could replace with a u, and so I could write this as 2 over uu, or 2 over u squared du. And now I can take that antiderivative and get 2u, well, I'm going to rewrite that first. Take that antiderivative and get 2u to the negative 1 times negative 1 plus c, which is negative 2 times e to the negative, or e to the radical x to negative 1 plus c, which I could rewrite as, if I really wanted to, negative 2 over e to the negative, or e to the x, negative 2 over e to the radical x plus c. So maybe you don't trust that kind of trickiness in there was valid. And I actually don't trust myself. So I'm going to take the derivative of this and see what we wind up with. So I'm going to check down here. So let's see what happens. So first we multiply by the negative 1 and we get 2 e to the radical x to the negative 2. The plus c goes away. Then we're going to multiply by the derivative of that, which is e to the radical x. Then I'm going to multiply by the derivative of the inside, which is 1 over 2 root x. Okay. That's a lot of stuff. But let's start cleaning it up. Okay, so this is 2, and this is 1 over e to the radical x. And since it's squared, so that means there's 2 of them. We have e to the radical x up here. And then we have that down there. So I see a 2 on the top and a 2 on the bottom, so I can cancel those. I see 2 of these down here and 1 of these up here, so I can cancel those. And we are left with 1 over, there's a radical x, there's an e to the radical x. Okay. So it absolutely checks out. If you found another way to approach this integral, I really want to know. This is hands down probably the toughest integral we have done all year. The idea that after we pick our u value, we didn't even use u for a while is really strange. I think the first year that I taught calc, I don't think I would have been able to do this problem. I think experience has brought me through, and now I'm less afraid of hitting a roadblock. You really have to get over that fear of, well, maybe this won't work. Okay, maybe it won't. It's still worth trying. So, all right. Oh, so now we just have bounds on them. So, dropping the difficulty level back down. So if we set u is equal to negative x, then du is equal to negative dx. So negative du is equal to dx. So this is equal to negative from 0 to 1 e to the u du. So from 0 to 1, sorry. So that's negative e to the u, evaluate from 0 to 1. But remember, we're not doing these bounds yet. We got to plug x back in. So remember, when we're plugging in bounds, we don't need to do plus c. So that's negative e to the negative x, evaluate from 0 to 1. We'll plug them in. So that's negative e to the negative 1 minus negative e to the negative 0. So that's negative 1 over e minus negative 1. So you could leave it like that, or you could do e over e here and get negative 1 plus e over e, or e minus 1 over e, or whatever decimal your calculator gets. Hooray! All right, this one. So this one also looks pretty straightforward. If our u is equal to 1 plus e to the x, then our du is equal to e to the x dx, which that's a pretty perfect line up there. So from 0 to 1, we have our 1 over u du. So our integral is the natural log of the absolute value of u, and we're going to be evaluating it from 0 to 1, but we need to plug x's back in. So it's the natural log of 1 plus e to the x, evaluated from 0 to 1. So if we do that, we plug in 1, we get the natural log of 1 plus e to the 1 minus the natural log of 1 plus e to the 0, which is the natural log of 1 plus e. We can't simplify that anymore. We could use our calculator if we really want to get the decimal, but I don't care about that right now. And that e to the 0 is 1, so that's the natural log of 2. And that would be the way that I would leave that. Or since we are subtracting 2 logs, we could write the natural log of the absolute value of 1 plus e divided by 2. That'd also be good. And our final one, the announcements are about to come on, so if they interrupt me, sorry. So if we set our u value to that, then it's a cosine of u. So if u is equal to e to the 4x, then du is equal to 4 e to the 4x dx. So we just divide by 4, get our 1/4. Du is equal to e to the 4x dx. So from 0 to -1. Oh, that's kind of weird. That's not the way we're supposed to do that, but it's fine. We will just plug in the bounds regardless. We're usually supposed to go from -1 to 0. We're supposed to go from least to greatest, but we can follow whatever the problem gives us. There's a fourth out front. There's a cosine u du. So antiderivative of cosine is sine, so we wind up having a quarter sine u from 0 to -1, or a quarter sine e to the 4x from 0 to -1. And if we drop those in, we have a quarter sine
Good morning, Dickinson. Please stand for
e to the
the
-4 minus a quarter
Pledge
sine.
allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please remain standing for a moment of silence.
Have fun.